Good afternoon, class. I hope everyone is having a great day. Today I would like to take a look at the assignment heat loss and gain. Now in this assignment, the goal is to calculate the total transmission load or the total heat loss from the utility shed. Okay, so what I would like to do with you is actually get you started on this assignment by completing Table 1 and Table 2. And both of these tables are located on page 2. And I would also like to start table number 5. Now there's several sections on table 5 on page 4, but I would like to do 2 of the rows with you. And I'm going to walk you through the calculation. So in table 1, for the utility shed walls, we are going to calculate the total transmission load through each wall. Now I am going to complete the west wall with you. So as you see here in table 5, one of the rows is the west wall. So we are going to calculate the total transmission load through the west wall, okay? So right here, we are given a list of different materials, and in your appendix section in the assignment, in the very back of the assignment, you have a materials list. And we have 2 different sections for each material, R value per inch or R value per unit, okay? So let's go ahead and start in table 1. We have 1/2 inch OSB. OSB, remember, stands for oriented strand board, and this specifically is the low density OSB. So in your appendix, you are given this value. I wrote it on the board here, so OSB, low density. Now it says R value per inch, 1.41, but we only have 1/2 an inch. We don't have an inch, so we're going to multiply this by 1/2. So 1.41 times 1/2 is going to be 0.705. Then we have the inside air film. So once again, we would look in the appendix of the assignment. We would locate the inside air film, and we have an R value per unit of 0.68. Then R11 batt insulation. So the R value for R11 batt insulation is 11.0. So when insulation tells you the name of it by R11 or R19 or whatever the R value is, that is literally the rating of the R value. So this is 11.0. Then we have another layer, 1/2 inch OSB, low density. So we already have this value here, 0.705. Then we have vapor barrier. So on our list of materials, vapor barrier, this is 0. And then we have a piece of 3/4 inch by 10 inch wood bevel siding. Well, wood bevel siding, 1.05. Now, what we would do is we would add all those values up, and so we're going to get 14.14. And since this is an R value, we would have units of foot square, hour, degree Fahrenheit per British thermal unit, okay? And so what we're going to do is we're going to take this value, we're going to turn to page 4, so we're looking at table 5 now, and it says the assembly R value for the west wall. Well, we just calculated it right here, 14.14. Now it wants us to calculate the U factor. Now to calculate the total transmission load, we're going to use the equation Q prime equals AU delta T, where A is the area in square feet of our surface, U is the U factor, which is the inverse of our R value, and then we have delta T. This represents the difference in temperature between the inside and outside temperature. So right here we have, let's go ahead and look at U factor. So U factor And I'm just going to add a subscript here of west to identify the west wall. This is going to be 1 divided by the R value of the west wall. Okay, so 1 divided by 14.14. And remember, we have units of foot squared, hour, degree Fahrenheit per BTU. Okay, so let's do 1 divided by 14.14. So let's go ahead and get out our calculator. And I get 0.070721. And what we're going to do for the U factors, we are always going to truncate to the thousandths place. So we are not rounding, we are not applying the rules of rounding. So our value is going to be 70 thousandths. So 0.070. Now, taking a look at our units, since we did the inverse of the R value, our units are going to be British thermal unit per foot squared, hour, degree Fahrenheit. Okay? Now, for the area in square foot, let's turn to page 5. And on page 5, you have something that looks like this. Okay, so we're going to take a look at the west elevation. So the west elevation is in the top row in the right column. So we have a picture here, and we have our overhang there. Okay, but what we're interested in is the wall, the west wall. So the height of the wall is 8 foot, and then the width of this wall is going to be 16 foot. Okay, so let's calculate the area there. I have base times height. 16 times 8 is going to give me 128 foot squared. Okay, so let's put that in our space up here, 128, and our units are square feet. Now delta T on the front page, on page 1, under the assumptions, right here in this middle section, it says the desired inside temperature is 70 degrees Fahrenheit and the outside temperature is 9 degrees Fahrenheit. So we're calculating the temperature difference. So delta T is equal to the temperature inside minus the temperature outside. So this is going to be 70 degrees Fahrenheit minus 9 degrees Fahrenheit, and that's going to give me 61 degrees Fahrenheit. Okay? So now I'm going to erase here because we need to calculate the transmission load for the west wall. And we're going to use this, Q prime equals AU delta T. All right, so I have Q prime. And I'm going to use the subscript of west to help describe that we're calculating the transmission load through the west wall. My area, we'll use our calculated value, 128 square feet. Please remember to write your units down here. Now our U factor, so U factor, 70 thousandths. And this is going to be British thermal unit per hour times square foot times degree Fahrenheit. And delta T, remember delta T represents the difference between the inside air temperature and the outside air temperature. So this is 61 degrees Fahrenheit. So what we're going to do is we're going to multiply these values together. And let's just talk about the numerical value first. So Q prime of west, of the west wall, is going to be 546.56. And now let's take a look at units. So we have foot squared times BTUs per hour, foot squared degree Fahrenheit. Now algebraically we can write this as foot squared over 1. So when I multiply these two unit values here, I have foot squared in the numerator and then I have foot squared in the denominator. Those will cancel. Next, I have British thermal units per hour degree Fahrenheit. We're multiplying by degree Fahrenheit. And we can write this Fahrenheit over 1. So I have a degree Fahrenheit in the numerator, and then I have another one in the denominator. So those will cancel, leaving me with units of BTUs per hour. And that's right where we want to be. That is what we need. So we're going to write our calculated value in table 5, transmission load for the west wall. So 546.56. Okay? So I'm going to erase this here. All right, let's take a look at table 2. So let's turn to page 2. We have table 2. We're going to follow the same process that we did for table 1. But table 2, we are now listing the materials and the R values for these materials for the ceiling or the roof. Okay, so the asphalt shingles, what you can do is look in your appendix and locate asphalt shingles, although I have my list of materials on the board here. So we have R value per unit is 0.44. Then we have roof felt. This is going to be 0.06. We have the 1/2 inch OSB. This is our low density oriented strand board. So 1/2 inch of that is 0.705. R19 insulation, so our R value is 19.0. Inside air film, let's take a look here, 0.68. And then we have our 1/2 inch drywall. So the R value per inch is 0.90, but we only have 1/2 inch. So we're going to multiply 0.90 by 1/2, and this is going to give me 0.45. And so what we're going to do is we are going to add these values together, and this is going to give us 21.335. Okay, and this is going to give us units of foot squared, hour, degree Fahrenheit per British thermal unit. So let's copy our calculated value into the assembly R value space for our ceiling and roof, 21.335. Okay, now we need to calculate the U factor. Remember that the U factor is the inverse of the R value. So U factor, and I'm going to use the subscript of roof. This is 1 over the assembly R value. So 1 divided by 21.335. And we have units of square foot, hour, degree Fahrenheit per British thermal unit. Okay? So 0.046871. But remember, for our U factor, we're going to truncate at the thousandths place. So we are not applying the rules of rounding. We're just going to keep this value in the thousandths place. So this is going to give me 46 thousandths. Okay? And right here, we're going to have units of BTUs per square foot, hour, degree Fahrenheit. Okay? So now that we have calculated the U factor for the roof, I'm going to go ahead and erase this. Now what we're going to do is calculate the area, the total area of the roof. Now on page 5, we have an elevation, and we have a gabled roof here. Let's take a look at page 5. All right, so on page 5, in the left-hand column and the middle row, all right, we have the north elevation right here, okay? It says our total height is 10 foot, 4.5 inches. And at our roof line here, this is 8 foot, okay? We have 12 foot width of our shed. So what we're going to have to do is we are going to have to calculate our hypotenuse value here, okay? So we have 6 foot here, and if this is 10 foot, 4.5 inches, and this is 8 foot, that means this is 2 foot, 4.5 inches, okay? Now, what we need to do is go ahead and convert these values into inches, because this is going to be a weird decimal value that's going to be hard to convert back to inches later on. So 6 feet is 72 inches. And then our height value, so 2 feet is 24 inches, so this is going to be 28.5. So 28.5 inches and 72 inches. So what we're going to do is calculate this hypotenuse value, and we're going to use the Pythagorean theorem, okay? So I'll say this is side length C, so we know C squared equals A squared plus B squared. And I'll just call this side A, and this side B, okay? So for A, we have 72 inches, and we're going to square that, plus 28.5 inches, and we're going to square that. So let's get out our calculators. 72 squared is 5,184 inches squared. So not only are we squaring the numerical value, we are also squaring the unit value. That's why I have the inches squared, plus 28.5 inches squared is 812.25 inches squared. Let's add these values together. And this is going to give me 5,996.25 inches squared. Now, we have a squared on the left-hand side of the equal sign. So what I'm going to do is take the square root of both sides. So this is what I have going on right now is C squared equals 5,996.25 inches squared. So to eliminate the squared here, I'm going to take the square root of both sides. So our square root and our squared, they're going to cancel. So side length C is going to be the square root, 77.435. So not only are we taking the square root of the numerical value, but we're also taking the square root of the unit value. So the square root of inches squared is just inches. Okay? And so now we need to multiply this by from this elevation view by the depth of our roof. And looking on page 5, so our roof depth is going to be 16 feet. So what I'm going to do, and I'm just going to label this 77.435 inches and 16 feet. We need to convert that into inches, so 16 times 12. That's 192 inches. Now what we want to do is calculate this area. But when we do that, we're only calculating the area for one side. So this area that we calculate, we're going to multiply that value by 2. So we get the total area of our roof. So 192 times 77.435. That gives us 14,867.52. Let's multiply that by 2. And this is going to give me 29,735.04 inches squared. Now, when we use our transmission load equation right here, our area needs to be in square feet, not square inches. Sorry, my unit is square inches here. So we need to use some dimensional analysis right now and convert from square inches to square feet. Okay? All right, so we know that there are 144 square inches in 1 square feet. Okay? So what we're going to do is we're going to cancel those. So our value of 29,000, we're going to divide that by 144. And that's 206.493. Square feet. And just to make the numbers a little bit easier, I'm just going to go ahead and round this up to 206.5 square feet. All right, our temperature difference between the inside temperature and the outside temperature, it's still 61. Remember that we have an inside temperature of 70 degrees Fahrenheit, outside temperature of 9, so 61. Okay, I'm going to do some erasing here. And we're going to use our equation to calculate the transmission load. So Q prime is equal to AU delta T. All right, so transmission load for my roof. My area, we've calculated that, 206.5. Remember, always write your units down. Our U factor is 46 thousandths. This is British thermal units per hour, degree Fahrenheit, foot squared. And we're going to multiply this by 61 degrees Fahrenheit. Okay, so we're just going to go through the same process like we did last time. We know that our units of foot squared will cancel, and we know that our units of degree Fahrenheit will cancel, leaving us with units of British thermal units per hour. And this gives me 579.44 BTUs per hour. So our calculated value for transmission load, let's go ahead and write that on the ceiling roof row. And this is table 5 and it's located on page 4. So 579.44. Okay, so you have on your table 5 on the assignment, you have several more surfaces to calculate. And what you're going to do at the end of the assignment is add up all of the transmission loads for each surface, and that is going to be the total transmission load. Okay? So if you have any questions on this assignment, please let me know. You can give me a call or send me an email. I hope you have a great day.